In this homework, I'm going to give you some advice about completing homework 11 about model selection. The data we're going to use is an ALR3 package called Mantel. It's a contrived data set to illustrate some issues. The first thing we do in the Markdown file is we load the Mantel data. We summarize the fact that in our data set we have a response Y, 3 predictors x1, x2, x3, and in line 31 we make a very simple model explaining Y as a function of just an intercept, and in line 32 of the Markdown file we make a full model explaining Y as a multiple regression model of x1, x2, and x3. And then in line 33 we give a summary of our full model, and you should notice from this summary that when we have all 3 predictors in the model, we have an amazingly small residual standard error, and our R-squared is basically 1. That would be something you would notice from this, that basically this is a perfect model. The 3 predictors produce a perfect prediction of the response. In line 37 we do a scatter plot matrix of the data, and you will notice a few sort of strange things. x1 and x2 predictors are very correlated with each other. They're almost perfectly correlated with each other. x1 and x3 and x2 and x3 are not perfectly correlated with each other. You will notice that Y is, the response is more closely related to x3 than any of the other 2 predictors. It's almost a perfect relationship with x3 except for the one case out here that's not perfect. In part A, it says do a forward selection method, and for that we use the step function, and we start with model M0. Remember, that's the model that doesn't have any predictors in it. And then we are going to give it some scope information, tell it where to select from, and so forth. We'll tell it that the lower bound of what we will permit is an intercept. That's what tilde1 means. We'll allow a model as small as just having an intercept, and the biggest, most complex model that we will allow is this upper setting, permitting a model like x1 plus x2 plus x3. We're going to do forward selection, and that means we're going to start with our lower initial model M0, M0 that doesn't have any predictors in it, and we're going to move forward and add one term at a time as long as those terms contribute significantly to the model. And you'll notice the output for this tells us the starting AIC statistic for a model that only has an intercept, and then it gives you information about what the AIC statistic will be like if we add x3 to a model with an intercept, whether we add x1 or whether we add x2 or whether we do nothing. And notice the AIC statistics for each of those choices. And then the procedure continues, and it chooses to allow x3 in the model with an AIC statistic of negative 0.31, and it shows you what would happen if we added either no additional variables or if we added x1 or x2 on top of a model that already had x3 in it. And then finally it gives us the final result after it stops adding terms, and we get this particular model here that has x3 in it. So as a result for part A, I want you to list the predictors that wind up in the final model and just give me the name of the predictors that enter the final model according to this output. And then we move on to part B. We are going to do backward selection. We are going to start from the full model, M full, and we're going to allow a model as simple as an intercept, and the most complex model we will allow has all 3 predictors. and we start the backward elimination procedure, and we start with a full model in the AIC statistic that's given here. Oh, I forgot to mention, remember, we always want AIC statistics to be smaller is better. So we will add or remove terms from a model in order to improve the AIC statistic, which means in this case making it a smaller number on the number line. So we start with an AIC statistic of negative 285.8, and then we consider dropping terms, and you'll see what the AIC values are for each of the different possible candidates. And then we proceed through dropping terms until the model selection ends right here with our final model from backward elimination. Notice that the R-squared for this final model is also 1, almost a perfect explanation here. In line 55 of the Markdown file, I want you to give me the predictors, the names of the predictors which enter our final model. And then in part C, line 59, I want you to talk about what has happened in parts A and in part C. Tell me about, what has happened, what is similar, what is different about the final models for both of those two methods. Talk about things that you notice being similar or different, and put that discussion right here in line 59. And finally, I want you to consider all of the output that's been in the assignment so far, and I want you to tell me what you think the right model is. In other words, what predictors should be in the best model, and what is the best model. Tell me what it should be. And I want you to give some discussion about why the forward selection and the backward elimination methods didn't agree. So look at what gets added and subtracted by the methods and try to understand why we got the output that we did, and put that discussion right down here in line 69 of the output file. You will notice in part D of the output I've given you a code block that produces added variable plots. And I thought this might help you in your discussion. Remember that added variable plots are looking at adding a particular predictor after all others have been included. And you can see that if x2 and x3 are in the model, adding x1 will produce some benefit. If you look at this added variable plot, if x1 and x3 are in the model, it looks like adding x2 will give some additional benefit. But on this last one, if x1 and x2 are already in the model, it looks like adding x3 doesn't show any evidence it's going to do anything. And this might help you in your discussion. You don't need to talk about these added variable plots in particular, but I thought they might be helpful. That's why I've included them. And I hope this helps you complete homework 11.